Now we are going to study how to find the area of a triangle by different methods. Here what we are doing is we first find the area of the triangle by normal method, then trigonometry method, Heron's formula method, and coordinate geometry method. These are the various methods of finding the area of a triangle, and the formula keeps changing depending upon the method. So let us start with the first thing. So let us know first what is area. Concept of area. Now what is area? Area is a region enclosed by a closed figure. A closed figure is there. The region which is inside the closed figure is the area of the figure. Let us see this. Let's take a graph sheet. Now let us take a closed figure. Closed figure. Now let us draw a see. So this is a closed figure. Now we are going to name it. Let me name it. A, B, C, D is the name of the figure. Now, what is this? This is a rectangle, and this is 1 square centimeter. This is the second square centimeter, third square centimeter, fourth square centimeter, fifth, six, seven, eight, nine, 10. So it is enclosing 10 squares of 1 centimeter each. What it is doing? It encloses one 10 squares of 1 centimeter each. So what is it? And so in the adjoining figure, ABCD is a rectangle. It encloses 10 squares of 1 centimeter each. Therefore, area of the rectangle is 10 centimeter square. So we got the area. That is a concept of area. That is how many square centimeters or square meters whatsoever is enclosed within the closed figure. That is the area of the figure. So the area is 10 centimeters square. Now, if you see the length, this is 2 centimeter. AB is 2 centimeter. BC is 5. 1, 2, 3, 4, 5 centimeter. Now, if you see, this is 2, this is 5. So, the in the rectangle BC, that is the length of the rectangle is 5 centimeter, and the AB is the breadth of the rectangle, which is 2 centimeter. Now, if you see, here 5 into 2 is 10. And what is this 10? It is the area of the rectangle. So if it is the area of the rectangles, and from this we can conclude that area of a rectangle is length into breadth. That is L into B. Okay. Now, area of a parallelogram. Now, we have taken a rectangle. Let us slightly bend the rectangle. See, let us see how it is. Let us bend it here. So it's bent here. So it is seen clear. Now, when you bend it, this takes this something shape. So rectangle, the same rectangle, we have just bent it. That means the area enclosed is 10 centimeter, 10 squares. That is 10 squares of 1 centimeter. So what is the figure now? This is it's a parallelogram. Now, area of a parallelogram we have to find. So to find the area of the parallelogram, we let us modify this figure. In what way I'm going to do? What I'm going to do is I'm going to cut out this triangle part from here and attach it here so that the figure just slightly gets modified. Now you see how it is. I've taken the graph. Now I just cut out this portion from here, and this part I'm going to attach here. Here it is attached. Now I'll join this. When I join this, it comes here. Now you see this has become a rectangle. So let us name this point which was here. Let us come here. Now let us name this as B. So this is B, and this will become C. So ABC is a rectangle now. Okay. So ABC is a rectangle. That means the parallelogram has become a rectangle, and the area is 10 centimeters square. So you see here, this is 2 centimeter, and this is 5 centimeter. So now the parallelogram is a rectangle with length 5 centimeter, and breadth 2 centimeter. So length becomes the base of the parallelogram. So this length BC, that is the base here. So it becomes the base of the rectangle, and breadth becomes the distance between the parallel sides AD and BC. This is AD, this is BC. The distance between them is the breadth of the rectangle, and with this breadth, in case of a parallelogram, we call it as the height of the parallel. Okay? So when it's the height of the parallelogram, then area of the parallelogram is base into height. Okay? So that's how you find the area of a parallelogram by multiplying base and height. Now let us find the area of a triangle. Now triangle, when you say, see, this is the parallelogram which we are having. So here in this triangle, this is the base of the parallelogram. This is the height of the parallelogram. What do we do? Area of the parallelogram is base into height, which is just we have seen. Now let us join A and C. When you join A and C, so joining you get that triangle here. So suppose I join this, you'll get one triangle here, isn't it? See, it is a triangle here. So we are getting triangle ABC. So this is a triangle. Therefore, if you see in this triangle ABC and ADC, in these two triangles, AB is equal to DC and AD is equal to BC. Why? Because they are the opposite sides of the parallelogram are equal. Opposite sides of a parallelogram are equal. Therefore, these two opposite sides are equal. And AC is equal to AC. This side is common to both these triangles. That means these two triangles are congruent by SSS congruency. We have learned in lower classes and ninth also that this is a congruency. That means triangle ABC is congruent to the triangle. So since these two triangles are congruent, their areas must be equal. So since the triangles are congruent, their areas must be equal. So the area of the triangle must be half the area of the parallelogram. So area of a triangle is half into area of parallelogram, that is base into height. So half into base into height is the area of a triangle. So here that's how we have arrived at how to find the area of the triangle or how it was reduced. So this is what the area of a triangle is. Now let us see what is area of an equilateral triangle. What's an equilateral triangle? A triangle having all three sides of the same length is an equilateral triangle. So now what happens? This is a triangle ABC. The length of the side is A, this is also A, this is also A. All three sides are of the same length, therefore it's an equilateral triangle. Okay, the perpendicular from here to here, that is a base, is the height of the triangle. When you draw a height of the triangle, it divides the base into two equal halves. So if the whole length is A, this is A by 2, this is also A by 2. Yeah. So let all the sides of the triangle be A and height be H. So triangle is all sides are equal to A. That means it's an equilateral triangle. If it's an equilateral triangle, now draw AD perpendicular to BC. When you take AD perpendicular to BC, then ADC becomes a right triangle. This is a right triangle. So when we use Pythagoras theorem for this triangle, what do you get? What is Pythagoras theorem? This square plus this square is equal to AC square. So AD square plus DC square is equal to AC square. Now what is AD? AD is H. So let us replace this with H. And DC is A by 2. So let us take it as H square plus A by 2 whole square is equal to A square. AC is A. So it is A square. Now let us take this term to the right side. When you take it to the right side, it takes H square is equal to A square minus A by 2 whole square, which is A square minus A square by 4. Now let's take LCM here. When you take LCM, LCM is 4. So it will become 4 a square minus a square upon 4. 4a square minus a square is 3a square. 3a square upon 4. H square is this much. Take the square root of both the sides. When you take the square root of both the sides, it becomes square root of a square is a, and 3 is not a perfect square, therefore it remains inside the root sign. Root 3 upon square root of 4 is 2. So h is equal to a root 3 upon 2. We have found the height of this triangle in terms of the side length. Clear? Now, area of an equilateral triangle is what? Half into base into height. That is half into a is the base length, and height we have just calculated a root 3 upon 2. So if you see here, a into a square, root 3 into 1 is root 3, 2 into 2 is 4. So area of an equilateral triangle is root 3 by 4 into side square. A is the side of the equilateral triangle, therefore area of a equilateral triangle is given by root 3 by 4 into side square. Now let us see find the area of an isosceles triangle. What's an isosceles triangle? An isosceles triangle is a triangle having two of its sides equal. So this is a isosceles triangle. This side and this side both are equal, and this is a perpendicular, and perpendicular divides the baseline into two equal halves. So it is b by 2, b by 2. And this is the height of the triangle. Now, so a triangle having two of its sides equal is an isosceles triangle. So in an isosceles triangle, the perpendicular from the vertex bisects the base. This is a perpendicular from this vertex. It bisects the base. Okay, let us try to prove this. So first draw AD perpendicular to BC. When you draw AD perpendicular to BC, so here you have these two triangles, ADB and ADC. In these two triangles, AB is equal to AC. These two are given equal to A. It is given equal to A. Angle ADB is equal to ADC equal to 90 degrees. ADB and ADC both are equal to 90 degrees because it is AD is perpendicular to BC. And AD is common to both these triangles. Therefore, these two triangles are congruent. That is this triangle and this triangle. Both are congruent by RHS congruency. If these two triangles are congruent, that means BD and DC must be equal because they are the congruent parts of congruent triangles. That means each of them should be B by 2. Okay. Now you see, if this is B by 2, we have proved this is B by 2, this is H. So let us apply Pythagoras theorem here. So ADC is a right triangle. Because it's a right angle triangle, therefore, by applying Pythagoras theorem to this triangle, we get AD square plus BC square is equal to AC square. AD is H and DC is B by 2. So let us substitute here. H square plus B by 2 square is equal to A square. Now take this B by 2 whole square this side. You'll get H square is equal to A square minus B by 2 whole square. H square is equal to B square upon 4. Take LCM, it will become 4A square upon B square upon 4. Take the square root of both sides. So it becomes square root of 4A square minus B square upon 2. Because square root of 4 is 2. So here what is A? A is the equal side and B is the base length. This is a triangle which you have, and this is the H value we have calculated. Now, let us see what is the area. Area is half into base into height. So base is B. So let us write it B, and height is this. We have put this value. So if you see here, this is 2 into 2, 4, and this multiplies. So it becomes B into root of B, 4A square minus B square upon 4. So area of isosceles triangle is given by this formula. Here A is the length of equal sides of an isosceles triangle and B is the base length. Or you see, this is in the form of A square minus B square. So that is, if you're using the identity A square minus B square, you can write it as A plus B, A minus B. So this formula can be remodified and written as B bracket 2A plus B, 2A minus B upon 4. where A is the length of the equal sides of an isosceles triangle, B is the base length. Okay, so area of a triangle, that is isosceles triangle, where A is the two equal sides and B is the base length. It can be either written in this form or in this form, depending upon our convenience. This is easier so that you can simply add and subtract. Next, area of a triangle using trigonometry. Now, we have seen how to find the area of a triangle. Now, if you use trigonometry to find the area of triangle, let us use trigonometry to find. See here, again I take a triangle ABC. This is the height. This is, okay. Now what I do is, here what I follow a method. In front of the angle A, I take that opposite side has length A. Front of B, angle B, I say that length is B. And length of opposite to angle C, the length of that side is C. So in this triangle here, in triangle ABC, let the length of the side opposite vertex A be A. Length of the side opposite vertex B be B. And length of the side opposite vertex C be C. Okay. So we are following a rule for like this. Now you see here, draw AD perpendicular to BC. When you draw AD perpendicular to BC, ADC is a right triangle. If ADC is a right triangle, now you see here, let us take the sine of this angle C. What is sine? Opposite by hypotenuse. Opposite is H, hypotenuse is B. So sine C is equal to H upon B. Let us take B this side. So B sine C is equal to H, the height of the triangle. Now what is the area of a triangle? Area of triangle is half base into height. Half base is A and height is this. So if you put half into A into B into sine C. Yeah. Now let us take angle B. When you take angle B, sine of angle B is H upon C. Opposite is H, hypotenuse is C. So H upon C. Take it this side. You can C sine B is equal to H. So area will be half base into height, which is half into A into C into sine B. Now if you notice these two formulas, if you take C, angle, sine of this angle, the side containing this angle, the arms of this particular angle C, these two lengths multiplied into angle C. So side containing the angle C, the arms of the angle C is to be multiplied, arm length of the angle C, that is A into B into angle C. When you take B, it is A into C, because this angle is here, its arms are A and C, therefore A into C, angle B. So if that is the case, then if you take angle A, what it will be? It should be B into C. So that means area can also be written as half into B into C into sine of angle A. So how it is? See? So this is exactly how. So that's how you have to remember. So here this condition was important, so that you can remember the formula easy. So what we have done, area of a triangle is the product of the sides containing the angles and the sine of the angle. Area of a triangle is the product of the sides containing the angle and the sine of the angle. Area of an isosceles triangle using trigonometry. Now when you use trigonometry, isosceles triangle, only two sides are equal. So here I am going to use this particular angle. Now this angle, when you draw a perpendicular, it divides it into two equal arcs. So let us see how it is. A triangle having two of its sides equal is an isosceles triangle, which you already know. So draw AD perpendicular to BC. When you draw AD perpendicular to BC, therefore in these two triangles, angle ADB is equal to ADC is equal to 90 degrees, because we have constructed or we have drawn them perpendicular. And AB is equal to AC is equal to B. These two sides are equal to B. Okay. And AD is common. Therefore, these two triangles are congruent by RHS congruency. Because these two triangles are congruent, BD is equal to DC. Congruent parts of congruent triangles. Because these two triangles are congruent, therefore, you can say BD is equal to DC is equal to half of BC, which is half of BC means half of A by 2, as shown in this figure. So A by 2, A by 2. Now also these two angles are congruent because they are the congruent parts of congruent triangle. Therefore, you will get angle BAC is equal to theta and these two angles are both equal to half of that. So this is already shown in this figure. So that's how we are. So this is half of these two angles. Now let us try to use trigonometry to calculate using this particular triangle ADC. Now see this is the triangle. Now in triangle ADC, sine of theta by 2 I am taking. Sine theta by 2 is A by 2 upon B, opposite upon hypotenuse. Okay, so this will become sine theta by 2 is A upon 2B. Let us take 2B this side. It becomes 2B sine theta by 2 is A. So this means length of A is equal to 2B sine theta by 2. Now let us take cos of this angle. Cos of theta by 2 is adjacent upon hypotenuse. So it is cos theta by 2 is h upon b. That is b cos theta by 2 is h. That is area is half into base into height. That is half into a base is a and height is h. Let us put the values. A is this and h is this. Let's put it here. Half into 2b sine theta by 2. A is this and b is b cos theta by 2. These two cancels. B and B is here. So B into B is B square. Sine theta by 2 cos theta by 2. So area of isosceles triangle is given also by B square sine theta by 2 cos theta by 2. Previously we have proved something it is as AB is area is equal to half A into B into sine C. So how is this and that related? Now see the connection between these two. So as a separate thing, I'm just taking up this case here. So B is the length of the equal sides of the isosceles triangle and theta is the angle included between the equal sides. Theta is included between the equal sides. Okay. So let us consider these two and see how it is related to the previous formula and this formula. Okay. So comparing the area formula of an isosceles triangle. What is the area formula which we got? We got this AB into sine C. Side there, these are the two arms of the angle C. So what is the angle now formula which we have got? New one, B square sine theta by 2 cos theta by 2. So how we correlate these two. Now you see here, using the trigonometry identity, sine 2x is equal to 2 sine x cos x. By using this identity. If you use this identity, if sine 2x, I take this as C, because it's 2x, I am getting only x. That means if this is C, this should be C by 2. So if you take sine C, it will be 2 sine C by 2 cos C by 2. So if you do that, so area of triangle is half into A into B into sine C. That is half into A into B, 2 sine C by 2 cos C by 2. 2 cancels. So AB sine C by 2 cos C by 2. Here AB, here in this isosceles triangle, both sides were equal, so it's B into B it became. Where it is not equal, therefore A into B sine C by 2 cos C by 2. Clear? Now we take the angle B. Half A into C sine B. See here, this is half A into C sine B. That is half into A into C into 2 sine B by 2 cos B by 2. So 2 cancels. AC sine B by 2 cos B by 2. And if it is angle A we take, then it is half BC into sine A by 2 cos A by 2. So that is cosine A by 2 cos A by 2. Okay. I think this is all clear for you how you are cutting it. Now let's see the next thing. area of a triangle when the length of the three sides are known. That we call it as the Heron's formula. Now, for a Heron's formula, let us see the first figure. This is a triangle. That means it's a all three sides are of different length. It's a scalene triangle. When we know only the length of the three sides of the triangle, how to find the area? That's the method which Heron shown, and therefore, in honor of his name, his the thing. So we call it as Heron's formula. So if you see here, PQR is a triangle. Length of side PQ is A, length of side QR is B, and length of side PR is C. And perpendicular from here, there is a height of the triangle. Let this length be x, and since the total length is b, so this should be b minus x. Okay. Now let us see how to do it. PQR is a scalene triangle. That means all three sides are of different length, with sides PQ equal to A, QR is equal to B, and PR is equal to C. This is the three side lengths given. Now, draw PS perpendicular to QR. PS. This is PS, which is perpendicular to QR. So we get two right triangles here. One is this PSR and PSQ. We get two right triangles here. So let us see in triangle PSQ. Because it's a right triangle, we apply Pythagoras theorem. Therefore, A square, this is the hypotenuse. Therefore, hypotenuse square is equal to square of the other two sides. Sum. So A square is equal to H square plus H square. A square is equal to H square plus H. So for H square will be, if you take this one this side, it will become H square is equal to A square minus X square. This is the first equation from this side. Now let us consider this side triangle. Now when you consider this triangle, in triangle, here this is a hypotenuse. C square is equal to B minus X whole square plus H square. Again we take this one this side, it becomes H square is equal to C square minus B minus X whole square. This is the second equation. So let us number this as first equation. This is second two. So both are H square. So let us equate these two. When you equate equation 1 and 2, we will get A square minus X square is equal to this. A square minus X square is equal to C square minus B minus X whole square. We use A minus B whole identity here. A minus B whole square, A square plus B square minus 2AB. So if it will be used there, it will become A square minus X square is equal to C square minus B square plus X square minus 2BX. Okay. Now let us open the bracket so that this will become negative, this is negative, this becomes positive. So if you open it, it will become A square minus X square is C square minus B square minus X square plus 2BX. Minus X square they cancel. You are left with only A square on this side, and here B square minus C square plus 2BX. Let us take this one this side, it will become positive because here it's negative, and this will become negative. It will become A square plus B square minus C square is equal to 2BX. Bring 2B below this, it will become A square plus B square minus 2C square upon 2B is the value of X. That is this length. This length is equal to A square plus B square minus C square upon 2B. Okay. Now see here, we have just now, from the equation 1 we have H square is equal to A square minus X square. This is your equation 1 which we have said. Now, this is A square minus B square. So if you can use the identity, A square minus B square is equal to A plus B, A minus B, where A is A and B is X. So now H square can be written as H square is equal to A plus X, A minus X. But what is X? We have just found. X is A square plus B square minus C square upon 2B. Let's put this value here. When you put here, what will happen? H square is equal to A plus A square plus B square minus C square upon 2B. The second bracket, A minus A square plus B square minus C square upon 2. Here, because of this negative sign, the signs will change. So it will be, now take LCM here. It will be 2AB. a square plus b square minus a square. Here it is 2ab minus this three terms. It is a square plus b square minus a square. Now this, because of this negative sign, we'll try to change the signs here. So this is your figure. So you should just remember this is how the figure looks. So it is a square plus 2ab plus a square plus b square minus c square upon 2ab minus a square minus b square plus c square. This, because of this has become minus, this also minus, and this becomes plus. Now if you look at this, a square plus b square plus 2ab, this is an identity actually. And if you were to take this as negative, minus sign outside, this also becomes, see how it is? Put this in a bracket, we'll get it like this, minus c square. And this is positive, so write this first, minus, and take a minus sign and put all these three in the bracket. When you put this bracket, this minus when you take, so it will become positive a square. This also will become plus, minus plus is minus. And this is positive, so it will become minus minus plus. So that means it becomes a square plus b square minus 2ab. And this is a square plus b square plus 2ab. This is again an identity. What it is? A plus b whole square minus c square upon 2b. And this is c square minus a minus b whole square. Okay. So here what has happened? A plus b whole square minus c square. So we are using this identity again, a square minus b square. Because this is square, this is the first term, a square, this is b square. So if you use that, it will be a plus b. That means a plus b plus c, and a, that is a plus b, minus c. Here again is a and this is b. So a, that is c, plus a minus b, plus into c plus a minus b. So minus a plus b. Okay. Now you see here it becomes 2b into 2b is 4b square. So let us write this, a plus b plus c, a plus b minus c. I rearrange it in such a way so that you get to some c plus a minus b, c plus b minus a. So first I'm all writing the positive terms and then following it with the negative terms, positive term following with the negative term. Okay. So now it's a multiplication. So that means all four brackets to be multiplied upon 2b into 2b is 4b square. It will be a plus b plus c. Then first I take a term. This is b plus c minus a. Then I take b term. That is c plus b minus b. Then I take a plus b minus c. So I just taken in an order so that I rearranged it so that minus a minus b minus c. It comes in a system of orderly manner. That is the main purpose. There are nothing to do with it. Just rearranging the terms. And 2 into 2 is 4, b into b is b square. So this is h square is this much. Okay. So what will be h? H will be the root of the whole thing, numerator, and square root of 4b square is only 2b. So this will be your h value. Now, let us see. Your figure is here. This is the h value we have calculated. Now, area is what? Half base into height. Base is b, and height is this formula. So let us write that. Half into b into this formula. Now, here at this stage, we consider, Heron has considered something called half the perimeter, that is semi-perimeter, and he denotes it as S. Semi-perimeter, half, this is a plus b, sum of the three sides is a perimeter, and divided by 2 means you are taking half the perimeter, and we call it as semi-perimeter and denote it by S. So S is equal to a plus b plus c by 2. Let us take 2 this side. It becomes 2s is equal to a plus b plus c. Okay. Now, if I take a this side first, what will happen? 2s minus a is equal to b plus c. Now let me take b this side. 2s minus b is equal to a plus c. Now let us take c this side. It becomes 2s minus c is equal to a plus b. Now see, a plus b plus c is 2s. So here if you see, a plus b plus c is 2s. Let us put this way. B plus C is 2S minus A. B plus C is 2S minus A. A plus C. A plus C is 2S minus B. And A plus B is 2S minus C. So let us substitute all this in this formula. See how it takes. S 1 by 2B. This is 2S. This is 2S minus A minus A. 2S minus B minus B. 2S minus C minus C. 2S minus C and this minus. So minus C minus A minus A is minus 2A. Minus B is minus 2B. Minus C is minus 2C. So if you write it that way, it will become B, 1 by 2B, 2S, 2S minus 2A, 2S minus 2B, 2S minus 2C. Now 2 common, let us start taking out 2 common from each of these brackets. Take out 2 common, 2S. From this bracket 1, 2 comes out S minus A. From this bracket 1, 2 comes out S minus B. And from this bracket also 1, 2 comes out S minus C. So when two 2's are there inside, 1, 2 will come outside the radical side. And here also we have got 2 2's. So one more row. So that means 2 2's will come outside the radical side. So if it comes like that, it will be 1 by 2b, 2 into 2, S minus A, S minus B, S minus C. So here, this B gets cancelled with this B. This 2 cancels with this 2. And this 2 cancels with this 2. So we are left only with this formula, that is, area of triangle is root of S, S minus A, S minus B, S minus C. This is your Heron's formula. Clear? So that's how the Heron's formula is derived. I think this is clear. Now, see, he used something called semi-perimeter. Now, I think you should think, why did he use semi-perimeter? What happens when we use perimeter? So, what if we use perimeter instead of semi-perimeter as used by Herons? How will the formula be? Let's see. Now, what is the height? Area is half into B into this. Now we are using perimeter. What is perimeter? Okay. Perimeter is A plus B plus C. Sum of the 3 sides is a perimeter. Yeah. So let me first take out P this A this side. P minus A is called B plus. Then take B this side. It will become P. P minus B is equal to A plus. Then take C this side. P minus C is equal to A plus B. Let's put all these values here. It will become A 1 by 2B P P minus A minus A P minus B minus B P minus C minus C. It will become this B will cancel with this P. 2 into 2 will be 4. And this is P minus 2A, P minus 2B, P minus 2C. So if you take perimeter as a thing instead of using semi-perimeter, you will have a denominator with 4. So that means you have to find all this and divide by 4. So this could be again finding the root and then dividing could be more difficult. That's why we prefer to use semi-perimeter, not the perimeter of the triangle. Yeah. So learn to think on it. So only then. Now area of a triangle using coordinate geometry. Now coordinate geometry means what? The coordinates x1, y1, x2, y2 is here. So let us see how it is. This is a triangle. Okay. The coordinates of this point is x1, y1. That is, this is from here to here x1, up to here, this is x2, x1. So this is x1 and this is y1. This is x2 and this length is y2. From here to here it is x3 and this length is y3. So the coordinates of A, B, C is x1, y1 and the coordinates of 3. So ABC is a triangle with the coordinates. A coordinate is x1, y1, B coordinate is x2, y2, C coordinate is x3, y3. You have to find the area of this triangle. So if you see when I draw perpendicular from A, B and C, I get a figure like this, which is a trapezium. I get a trapezium here. And this is also a trapezium. That means, see, I'll show you. So if you want to find the area of this triangle, you have to find the area of this trapezium, and subtract the area of this trapezium, you'll get the area of this triangle. See how it is. This is a trapezium. Now, there's another trapezium here. So I'll add these two trapeziums and subtract this from that. When I subtract this from that, I'll get what is the figure here. I'm getting the area of triangle. Getting it? So that's the concept we are going to use here. Okay. Now let us see how to do it. Area of a triangle using coordinate geometry. Now this is your figure. Now we have to find the length of this AL, BM and CN. All these lengths you have to find. So by now you must have understood that area of triangle is equal to area of trapezium ABML plus area of trapezium ALNC minus area of trapezium BMNC. So this will be the thing. So area of this trapezium and this, you have to add it and subtract this, you'll get the area of the triangle. Okay. So using distance formula, we find the length of BM, AL, CN, ML, NL, and MN. Now let us see what is distance formula. Suppose you have a line segment AB and coordinates of this is x1, y1 and coordinates of this point is x2, y2. Then the distance formula tells distance between the length points A and B is square root of x2 minus x1, x2 minus x1 whole square plus y2 minus y1 whole square. This is the distance formula. Okay. This is what we are going to use now to find the so many lengths. Now see, we have to find this length, this length, this length, three lengths. So here, what is it? See, first let us BM. I'm going to calculate the length of BM. What is BM? X2 and here also X2. So X2 minus X2 whole square plus Y2 minus 0 whole square. So X2 minus X2 is 0 and Y2 square it is. Y2 square, root and square will cancel, it will be only Y2. Now let us calculate this length. That is AL. X1 minus X1 plus Y1 minus 0 whole square. So it is x1 minus x1 is 0. So 0 square is 0. So y1 square, which is only equal to y1. Now Cn we are going to Cn is equal to x3 minus x3 whole square plus y3 minus 0 whole square. This is 0, so it is y3 square, this is y3. Now ml, this length I have to calculate. Okay, so this is x1 minus x2. X1 minus x2 whole square plus 0 minus 0 whole square. So this is root of x1 minus x2 whole square. So the square and root cancel, it is only x1 minus x2. Now let me calculate ln. ln is equal to x3 minus x2, sorry, x3 minus x1 whole square and 0 minus 0. So it is x3 minus x1 whole square is equal to x3 minus x1. Now you're going to mn. mn is x3 minus x2 whole square and 0 minus 0. That is x3 minus x2. Yeah. So we have calculated all the lengths and the distance between the parallel sides. So now area of a trapezium is half into height into sum of the parallel sides. So now we are taking this. This is the height and this is the parallel side. These two are the two parallel sides. So if you take A, B, M, L in this, so it is half, height is ML and the parallel sides are BM and AL, BM and AL. So that is half into ML. ML is here what? X1 minus X2. So put that X1 minus X2. Bracket BM. BM is Y2. Put Y2. And AL. AL is Y1. AL is Y1. Got it? So this is the area of the trapezium ABML. Now area of trapezium ALNC. ALNC is equal to the height is NL and these are the two parallel sides. So half NL into AL plus CL. That is half NL. NL is x3 minus x1, x3 minus x1, bracket AL. AL is y1 plus Cn is y3, y3. Yeah. Now take this triangle, trapezoid, this bigger one, this together. That is BMNC. So height is MN, and the two parallel are BM and CN. So half MN. MN is x3 minus x2, x3 minus x2. BM. BM is y2, and CN is y3, y3. Okay, so I got all the three areas. So now we'll have to add these two and subtract this. Now let us see how it is. Area of triangle is area of this trapezium plus area of this trapezium minus area of this. The values which you have already put, substitute them in this. Now half is it. Let us take out half outside. Half taken out and remaining all written inside the bracket. Now let's multiply all these. When you multiply it is x1 y2 plus x1 y1 minus x2 y2 minus x2 y1. First plus minus is minus. First bracket over. Now next x3 y1 plus x3 y3 minus x1 y1 minus plus is minus x1 y3 minus x3 y2 plus x3 y3 minus x2 y2 minus x2 y3. Okay. Let's open all the brackets. And open all the brackets. This is all positive. Nothing happened. Copy them as it is. Copy them as it is. Here there will be a change. This becomes negative. This becomes negative. This becomes positive. This also becomes positive. So plus x1 y1 minus x1 y1 cancels. Minus x2 y2 plus x2 y2 cancels. Plus x3 y3 minus x3 y3 cancels. So these 6 terms gets cancelled, and remaining thing we just put it down in this many are left. Now this is left, this is left, this one, the remaining terms. Now what I do, I bring all x1s first. I bring here there's an x1 term, here also x1 term. I write these two together. x2, x2, I write them together. x3, x3, I write them together. I just rearrange it. So x1, y2 minus x1, y3 plus x2, y3, okay, minus x2, y1 plus x3, y1 minus x3, y2. Now from this, both are having x common, so I take out x common. Here I am taking x2 common. Here I take out x3 common. So it becomes half x1 y2 minus y3 plus x2 y3 minus y1 plus x3 y1 minus y2. Okay, this is the area of the triangle using coordinate geometry. Now how to remember x1? After 1 what comes? 2, 2, 3. So x1, y2, y3. After 2, 3, 1 again. 3, y3 minus y1. After 3, 1, 2, 1. So half x1, y2 minus y3 plus x2, y3 minus y1 plus x3, y1 minus y2. This is the area of the triangle using coordinate geometry. Okay. Clear? I think this is clear now.